Hello and welcome to the U.S. Environmental Protection Agency's Decentralized Wastewater Webcast Series. Today's session is titled Surface Discharge of Raw Wastewater Among Unsewered Homes in Central Alabama. My name is Kevin O'Donovan. I'm an EPA contractor and I'll be handling the technical aspects of today's session. We will get started in a few moments. While we wait for others to log on, I will cover a few housekeeping items. By now, you should have the GoToWebinar application running and should see the welcome slide on your screen. If you are having technical difficulties using GoToWebinar, please visit gotowebinar.com and click on Support in the upper right corner of the page. You also may submit a question via the GoToWebinar Questions panel, and I will try and help you resolve your issue. We encourage you to ask questions at any time during the webinar. Simply use the GoToWebinar control panel. You can type your questions in the area that says Questions, and then click Send to submit it to the moderator. Please note that your GoToWebinar control panel may not be expanded and may look like a small gray rectangle with little buttons. You will need to expand it so that you can ask questions. To do so, just click on the orange button at the top of the gray rectangle. And with that bit of housekeeping out of the way, we are ready to start the webinar. I now will turn things over to Heidi Fowler of the EPA. Heidi?
Thanks, Kevin. This is Heidi Fowler. I manage the Decentralized Wastewater Program in EPA's Office of Wastewater Management. I want to welcome all of you and thank you for attending today. These webinars we have been putting on quarterly as part of the Decentralized Wastewater MOU partnership that EPA has along with 18 other organizations. And today's featured presentation is on surface discharge of raw wastewater among unsewered homes in Central Alabama. Today's presenter is Dr. Mark Elliott. He is an assistant professor of environmental engineering at the University of Alabama. Mark received his PhD from the University of North Carolina, and his current research at the University of Alabama focuses on global progress in drinking water and sanitation coverage, among other issues, as well as determining the scope and impacts of on-site wastewater failures in rural Alabama. So with that, I'd like to turn it over to Mark. And Mark, we are going to ask people to put their questions into the question box, and then at the end of your presentation, we will go through and select from those questions and ask as many as we can. Mark, all over to you.
Great, thanks, Heidi. Great, so I'm thankful to everyone for attending today. Hopefully we can get more people informed about this important and often unknown issue in the rural South. So I do want to first acknowledge my co-authors, not individually, but just to say this is a large team, multidisciplinary team, and this is not just my work that I'm reporting on today. So yeah, I am going to talk about direct discharge of household wastewater in rural Alabama. When I started at the University of Alabama 4 years ago as an assistant professor, people told me that many of the things that I had seen in developing countries during my PhD work and my work as a postdoc, I would see similar things in rural Alabama, and I kind of didn't believe them. But on my first trip out to do a household interview about water and sanitation, I actually had deja vu when I opened the door on a hot, humid day, and immediately was overwhelmed by the smell of sewage. And it reminded me of being in the rural Mekong Delta in Vietnam or in rural Cambodia. When I looked out, I found the trailer where we were doing our interview had a white pipe running to a pool of sewage about 20 feet from the home. And through that process and a lot of other investigations, I found that the problem that I hoped to investigate, which was failing septic systems, was actually not the biggest problem in rural Alabama, but actually homes where there was no septic system and where there was discharge of raw sewage through a so-called straight pipe. So I'll use the term straight pipe. What that refers to is surface discharge of untreated wastewater. Okay, so just a second. All right, so just to get everybody on the same page, when we talk about wastewater treatment in the United States, about 80% of people have a municipal system to which they discharge their wastewater to a sewer. So that's their water from their sink, from their toilet, from their shower, etc. From the washing machine. It all goes into a sewer and then is treated centrally at a municipal plant. That's nearly everyone in cities has those, most people in towns. In rural areas, about 60% of people don't have a centralized system and use an on-site system. So about 20% of the total population of the United States has an on-site system where they treat their wastewater, or technically where they should be treating their wastewater. So in the US, the vast majority of on-site wastewater treatment systems are conventional septic systems. And I just want to talk about those very briefly to make sure that everyone understands what I'm talking about. This is a cross-section of a conventional septic system. You can see a pipe leaving the home. It goes to a septic tank. In that tank, solids are settled to the bottom. So there's a settling process, and then anaerobic digestion occurs at the bottom. But most of the treatment of the wastewater occurs in the drain field and in the soil. So the liquid leaves the septic tank. It goes into a drain field, which is typically a trench between, at the extremes, kind of 1 foot and 3 feet wide, and about maybe 18 inches deep, that is filled with gravel, or with new infiltrator systems, they have empty chambers they have a plastic chamber that allows that trench to be empty. But the wastewater collects in that trench, slowly infiltrates into the subsurface, goes into the soil above the groundwater table. So it's in the dry area of the soil, and then percolates down into the groundwater. Okay, during that process, there's soil absorption and purification processes that go on that treat the wastewater. Septic systems in the right type of soil are a very affordable and effective way to treat wastewater. In the US, about 1 trillion gallons a year are discharged into the subsurface through on-site wastewater treatment systems. A conventional septic system will generally be maybe in the neighborhood of about $2,500. So in the context of a home, it's a very affordable solution. Alternative systems that are needed in some types of soils, whether a mound system or a drip system or an anaerobic system with pumps and multiple chambers, those are going to be at least $6,000 basically and up. So they quickly become unaffordable to the rural poor. So the counties in which we're focusing in Alabama are the so-called black belt counties. These counties were named for the rich, dark topsoil that was really good for farming cotton. But in many places of the black belt, that topsoil is underlain by clay that is extremely impermeable, or a chalk layer that's also impermeable, that prevents that infiltration process that is necessary with a conventional septic system to have effective treatment. The counties in gray on that map are the black belt counties. There was a study out of Auburn that came out in 2011 that found that based on the soil characteristics and the concentration of septic systems and homes in the black belt, about greater than 50% of the black belt area was unsuitable for septic systems. And poverty in this area limits the alternatives. So most counties in the black belt are about 25 to 40% of the population is below the poverty line and especially the rural population that lives outside of the towns where there is municipal sewer access. So there is some media coverage and anecdotal evidence that has pointed to a big problem in rural Alabama with on-site wastewater. The UN Special Rapporteur on the human rights to water and sanitation had a report in 2010 that specifically named Lowndes County as a place, Lowndes County, Alabama, which is one of the black belt counties, as a place where people were not enjoying their human right to sanitation. Al Jazeera had an online article in June 2015 identifying this problem and explaining this problem also in Lowndes County. And then the New York Times actually had an article in late September where they went through this problem also in Lowndes County, Alabama. There's a real advocate for the rural poor in Lowndes County named Catherine Flowers, who has who has managed through years of tireless effort to get media attention to this problem. Probably with this New York Times article being the pinnacle so far of that attention. I do want to mention that in the headline, the 500,000 U.S. homes is not actually talking about homes that don't have proper wastewater treatment or have a straight pipe. That number is unknown. The 500,000 U.S. homes is talking about homes that don't have some form of adequate plumbing. But the number that don't have proper wastewater treatment is unknown. I talked about some preliminary evidence, some anecdotal evidence, but how bad is the problem? We do have data from an adjacent county, Bibb County, Alabama, which is outside the Black Belt. It's actually north of the worst soils, the worst Black Belt soils. There was a study by Kevin White and Robert Jones that was published in 2006. It's a report. Even if you know the name of the report and the title of the report and the name of the authors, you really can't find it online. This is really something that's just passed among interested researchers. Someone emailed it to me about a year and a half ago. But it was a detailed study, physical inspections of nearly every home that wasn't connected to sewer in Bibb County. So that was about 4,000 homes. And after finding this report, I was very, I became very interested in the evidence and got in touch with the authors to try to collaborate. And we're now collaborating on some other counties that we'll talk about later. But let me talk briefly about the results for Bibb County and some insights that might give us into the state of on-site wastewater treatment in the Black Belt counties. So these were homes, these are homes, they just focus on the homes that were not connected to public sewer. They found that 35% of those had a failing septic system. This would include evidence like wastewater on the ground or extra growth of grass, very green areas along the field lines. An additional 15% of those had a straight pipe, so they actually could see a direct discharge of wastewater through a pipe adjacent to that home. So when I talk to stakeholders around the United States and researchers and tell them that there's a county in Alabama where 15% of unsewered households are directly discharging wastewater through a straight pipe, they're generally aghast and can't believe it. And there's a big contrast when I talk to stakeholders in rural Alabama, and I tell them that in Bibb County, 15% of people are using who don't have sewer are using a straight pipe, and that response is usually, "Wow, Bibb County is doing pretty well compared to the counties where I work," and that's not an exaggeration. That's a consistent response that I've gotten when talking to stakeholders who work on water and wastewater issues in rural Alabama. So just the images below are actually from Lowndes County. And these are images of wastewater accumulating in yards. Here you can see a ball, a child's ball has gotten into the wastewater. In the other picture, it's a dog, a pet dog lounging in the wastewater to stay cool during the summer. So in terms of health risks, when wastewater accumulates in a yard, you can imagine that that dog may be going in and out of the home. The kids may take that ball and play with it. That there are pathways for infection there. More typically, straight pipes, and these pictures are from Lowndes County, are directed to the woods if possible. So most people will take a PVC pipe and run it out to the woods so it doesn't discharge directly in their yard. You may be able to see in the photo on the right that that pipe is broken, so it actually the two pipes became separated, so it actually is discharging in the yard. But these are some things that I've witnessed in some of my trips to the rural areas. In some communities, straight pipes are not just common, but they're very much accepted and just part of the landscape, basically. So this is actually a picture from Hale County. You see this as well. There's a straight pipe in this picture, but you might not be able to see it. It's now circled in red. This is a home that is not adjacent to the woods. So their option for the straight pipe discharge to keep it kind of hidden was actually to bury it and run it to a drainage trench out in front of the house adjacent to the road. I didn't notice this. It was actually one of my students as we were driving down the road who spotted this one. So I thought I'd make a good illustration of of a straight pipe that was hidden from view for the most part. And you can imagine that that this household, this family, if they lived adjacent to the woods, they would probably discharge to the woods to keep it even more hidden and out of the way. So these maps are not meant to be detailed. They're very blurry. They're just to show that straight pipes and failing septic systems in Bibb County were not just located in certain concentrated communities, but were really spread throughout most of the county that did not have access to sewer. Okay, so what does that mean, 15% straight pipe in Bibb County? So in Bibb County, 15% straight pipe in that sample of about 4,000 homes means about 60,000 gallons per day of raw sewage being discharged to the ground every day in that county alone. Okay, so that's about 20 million gallons per year, 80 million liters per year. And this represents each day billions of pathogens being discharged into the water, just based on the common number of pathogens that are present in sewage. So we're talking about greater than 1 billion enteric viruses, 1 billion Giardia cysts, and 300 million Cryptosporidium oocysts discharged every day to the ground just in Bibb County, based on that 15% straight pipe. And that's not counting the failing septic systems and the number of pathogens that may be released by those. I do want to mention also that these pathogens are very robust in the environment. We're not just talking about bacterial pathogens for which E. coli, say, would be a good indicator, and the absence of E. coli would indicate the absence of the bacteria. Cryptosporidium and Giardia are very robust in the environment and maintain their infectivity. So even if E. coli that was discharged in the sewage died off, you might still have, it'd be very likely you'd still have infectious Giardia and Cryptosporidium. So let's compare Bibb County to the Black Belt counties to try to gain some insight. Okay, Bibb County has lower poverty levels than most of the Black Belt counties. The other counties we're working in, Hale County and Wilcox, based on the 2010 census, about 27%, 39% poverty. And of course, the people who are far from the sewers are more likely to be poor, the people who live further away from the towns. Possibly more importantly, the soil in Bibb County is not nearly as challenging for running a conventional septic system as it is in some of these Black Belt counties. So I think it's very likely, I think that we could determine at this point that it's very likely that straight pipe and failing septic system frequency is likely to be much higher in the Black Belt counties than it is in Bibb County. So if we have this much, discharge of raw wastewater, this many pathogens being discharged to the environment, shouldn't we expect to see some health impacts? Well, first of all, people in these rural counties have very poor access to health care in general. There are very few primary care physicians. In Hale County, which has a population of about 14,000 people, there were 2 registered primary care physicians when I checked, and in Wilcox County there was 1 for a population of about 10,000 people. So first of all, there's not a lot of access to health care. Second, even if people come in with some sort of gastrointestinal illness, for example, there's probably not a lot of surveillance for infectious diseases like helminthic parasites that are often thought to be diseases of the 19th century. So there was a survey specifically for helminths in Wilcox County in 1993. A UAB master's student named Amy Badham did the study for her master's and found that about 1/3 of children under 10 tested positive for 1 or more helminths. Helminths are worms in Wilcox County. And there's unpublished data from Lowndes County indicating that more than 1/3 of adults with poor sanitation were also infected with helminths. Georgia Tech, Joe Brown, who's on the faculty at Georgia Tech, is actually doing a follow-up with Amy Badham in Wilcox County starting this summer to follow up on her data from about 35 years ago to see whether this is still the case and actually apply some newer methods to this to detect those helminths. So basically, there are various lines of evidence pointing to on-site wastewater as a substantial threat to water quality and also to public health. So I took a, I started writing, when I started to hear about this evidence, I started writing proposals and was able to get some funding for this work through the EPA Gulf of Mexico program, through the Alabama Water Resources Research Institute that has a USGS funding that they have a few small grants that they distribute to universities throughout the state, and the University of Alabama Center for Freshwater Studies. So because we have a multidisciplinary team, it enabled us to do a number of different methods, actually also to get some subcontractors involved, including Robert and Lynn Jones to do the site-by-site inspections. So I'm just going to run through some of the data now based on these different methods, and describe some of the methods that we're using to investigate this problem, to try to figure out the scope and the impacts of on-site wastewater discharges in these rural counties. So, so starting with site-by-site inspections. So Bibb County is the one where the county where the data from the 2006 report, which I've already presented. We decided to do a smaller scale version of those in Hale and Wilcox counties. We couldn't achieve the same sample size that they did in Bibb County, but we are able to gain some insight into the scope of the problem in these counties. So, so starting with Wilcox County. In Wilcox County, we had about 289 dwellings surveyed. 104 of those were homes, like stick-built homes. 185 were mobile homes. This is pretty common in rural areas of Alabama, that you have majority mobile homes. And we tried to focus on a sample that was representative of county demographics and the soil characteristics. So in Wilcox County, we found. I also want to mention that Robert Jones, who was conducting this work, was actually the environmental area director for both Wilcox and Hale County when he worked for the health department. He's now retired, so he has connections at the health department and can confirm the permitting status for these homes. So, so during the survey, they found that about 7% of unsewered homes had a permitted on-site wastewater system. And so that means about 93% did not have a permitted system. 60% of homes, unsewered homes in Wilcox County, had a straight pipe that was visible upon inspection. This is a staggeringly high number. I really want to do further investigation to broaden the investigation both in Wilcox County and to other counties. But to this point, our sample, we're seeing a majority of homes that don't have sewer actually are using a straight pipe. In addition to that, the 34% of the sample that was unpermitted, it may have been some form of in-ground disposal, like there were field lines. It might be that someone had a septic tank but no field lines, or maybe like a 55-gallon drum, like they're trying to do something to contain their solid waste but discharging the liquid. Or they had a straight pipe that was buried or not visible. And you could see from that picture that I showed where there was a trench, that when someone wants to bury a straight pipe and keep it hidden, you can imagine that if their home was backed up against the woods, it'd be very easy to keep that hidden. So these data were collected by Lynn and Robert Jones. These maps, just some snapshots on a soil map of Wilcox County. I just want to illustrate a couple things, not go through the data in detail, but just zooming in here, you can see that of the homes along the more desirable property along the river, many people had permitted systems or likely some form of in-ground disposal, not a visible straight pipe. When you go, in this case, up the hill to an informal community of mobile homes, we find a majority of people had straight pipes that were actually visible. I do want to mention too, for those who aren't very familiar with mobile homes, that in mobile homes, if you look underneath, you can see where the pipe goes from the toilet. So it's often very hard to hide the presence of a straight pipe if you live in a mobile home and don't have the sort of apron to restrict that view underneath the home. So basically, the more expensive homes, the more desirable properties tended to have, were more likely to have permitted systems, and much less likely to have straight pipes. We find a lot of bunching of straight pipes in certain communities where the vast majority of households have a straight pipe. Some households are keeping them very well hidden. But you can imagine that when you live in a community where most people are discharging their sewage onto the ground, it's a clay area where you can't operate a conventional septic system, that the incentives, especially for poor households, there are few incentives to try to get a permitted system, like you can see from the one green dot on this map that one of these households had, and that there is a large incentive just to go ahead and run a straight pipe, which is a free solution to this problem. So that's Wilcox County. That's the county where we had the most, the highest frequency of straight pipe. Hale County, the preliminary data just came in over this weekend, so it's very preliminary, but there were 411 dwellings surveyed in Hale County. A slight majority of mobile homes in that sample. In Hale County, we found about 35% of the sample had health department permitted systems. I do want to mention that in most of, I'll say in many counties of rural Alabama, the presence of wastewater treatment is not enforced when there's a change, when property changes hands, or when electricity is hooked up, for example. So there is one municipality in Hale County, Moundville, in northern Hale County, that both has much better soil for septic systems, but also enforces a permitted, the need for a permitted system in order to sell property, to buy property, or to hook up utilities. So, like I said, the data just came in, but it appears that the majority of our permitted systems are in Moundville, that actually dictates that permitted systems are necessary. So among the 65% without permitted systems, 267 homes, we only had, I guess I maybe shouldn't say only, but 6% had a straight pipe that was visible upon inspection. So a much lower number, an order of magnitude lower than what we found in Wilcox County. But what that means is the majority of homes, we really don't know what they're doing. They don't have a permitted system, nor do they have a straight pipe that's visible. So it's either some form of in-ground disposal, but not permitted, so some form of drain field, or they have a straight pipe that's buried so as not to be visible. There's also kind of an in-between option where some households will have a septic tank but no drain field, where they're trying to get the solids out, or sometimes even a 55-gallon drum, where they're trying to get the solids out, but they are still discharging the wastewater, which does keep the majority of, does still have the majority of pathogens in it. Okay, and this is an image from Hale County. I just want to remind you, this is an image of a home that had a straight pipe that was buried well below the surface, and if they were adjacent to a wooded area, that would definitely have been hidden so that it couldn't have been found. Okay. So moving on, in addition to the inspection data, we wanted to supplement that with data from local stakeholders. The reality is that septic system installers and health department staff know a lot more about the state of on-site wastewater than any researcher sitting in his office at a university 100 miles away. So what we've tried to do is go to some of these people and talk through with a map some of the areas where they work and where they're familiar with, to figure out what they know about the state of on-site wastewater treatment. And these are estimates, you know, they're not hard data, but I think they can give some insight into some of these areas. I talked to a septic system installer named Tim Wenger, who has installed more systems in the area of New Bern, Alabama than anyone else. New Bern is an area of Hale County that does have the impermeable clay soil and is not connected to sewer. So he estimated that 10% of the people in New Bern have permitted systems. So about 90% would have an unpermitted system. Of those, he said that 40% would have some sort of field lines that have some sort of in-ground disposal, not a permitted system, but they're trying to get wastewater into the ground. And 50% of the sample, he estimated, of the total population of New Bern have straight pipes. Of those, he estimated that the majority of that 50%, 30% of the total sample, would have some form of solid settling. And 20% would have no solid settling, just a pure straight pipe that also discharges the solids. These are estimates, just based on his experience, his knowledge of the area and the systems that he's installed in the area. And oftentimes the people that have asked him to come and install a system, and then he tells them that if they want a permitted system, it's going to have to be much more expensive than they were planning, because it's going to be an alternative system, and oftentimes they don't call back. But yeah, the data that we just got over the weekend for Hale County, the sample from New Bern does seem to be similar to what was reported by Tim Wenger. The next method that we're using is flow routing, where the GIS groups at the University of Alabama in geography and in environmental engineering are doing some flow routing work for us, conducting drainage pattern modeling to determine if wastewater is discharged to the surface, or if it gets to the surface through a failed septic system, where does it go? And then how does flow accumulate at any point on the map based on the watershed? So this is just an illustrative example done by Mark Simpson, a master's graduate at University of Alabama, who did an excellent job developing this method. Basically, what we did is took a number of homes and said, if this home had a straight pipe, where would the wastewater go? That's indicated by the black pipe with the wastewater coming out. And then the icon, the red icon for the septic tank, indicates if someone had a septic tank and that was surfacing, where would that wastewater go? So I'll zoom in just a little bit so you can maybe see it, hopefully see it a little better on your monitors. But what this does is not just indicate the direction of flow from those potential straight pipe discharges, but it also indicates how much flow would accumulate to that point from rainfall. So the redder the line, the lower the flow. So basically in a deep red, there's almost no watershed area that's collecting rainfall to that area. When it gets to blue, to green and blue, then you have generally a more substantial flow. Sometimes a flow that goes away during the drier summer period. But this is really excellent work that we're trying to expand upon. Now that we have data on the locations of these straight pipes, we're going to try to actually implement this with some real data and figure out what the loading from these systems would be once it does rain. Okay, finally, we're doing water sampling, microbiological and chemical water sampling. We're looking at both base flow conditions, so during dry conditions we're taking samples, and then first flush conditions, and also taking samples under under recent rainfall. So base flow would be during dry conditions. The streams and rivers are fed by groundwater. In first flush samples, we have auto samplers. This is a stormwater sampling method where we install these auto samplers to collect the very first water that runs in a channel or a stream when the water level rises after a rainfall. We also have these ISCO auto samplers that we're trying to get running that can take samples spaced out over a longer period of time, take multiple samples. That's still a work in progress, trying to get those things working and in place. So we're choosing our sampling sites to ensure that we have control. So sites that are not impacted by any human activity. So we have some pristine sampling sites. Yuhan Liu, my collaborator in the geology department, has pristine sites in the study area. And then we're also looking at sites that represent the major geological and soil types. So places with a really impermeable clay, with a shallow chalk layer, places with an impermeable clay with a deeper chalk layer, and places with the better kind of sandy or loamy soil that can actually accept wastewater for infiltration. So we're using a multi-parameter approach, and our approach is based largely on the EPA urban illicit discharge detection methods that Professor Emeritus Bob Pitt from the University of Alabama established in his work with EPA. So based on the data that we get across a number of different parameters that I'll describe shortly, Yuhan Liu does statistical analysis with CART analysis, classification and regression tree, and similarity indices to try to figure out the components of the different, or the concentration of the different components in the sample and how that gives insight into how much wastewater may be in the sample. So for water analysis, we're doing typical fecal indicator bacteria, E. coli and coliforms using the IDEX Quantitre 2000 method, conductivity, turbidity, and pH. We're having anions and cations run in the geology, geochemistry labs, and also nutrients we're running, including nitrogen 15 that we're sending out to an external lab. We're also looking for human-specific bacterial genes by PCR and qPCR. We're trying to get that up and running. If successful, that has very high specificity, and also F+ colophages by single agar layer method. Those are viruses that infect bacteria, that infect E. coli. So we're also doing, through Yuhan's group and her lab in geology, dissolved organic analytes. We're doing fluorescence and organic matter fingerprinting and detecting the optical, and hopefully detecting the optical brighteners from laundry detergent as well. And okay, so that's the water sampling. The approach we're taking to water sampling. So just before we wrap up, I want to talk about some evidence of how widespread this problem might be. So it's not just Alabama. There is anecdotal evidence that direct discharge of sewage through straight pipes is common in rural Kentucky. There was an EPA Region 4 report that came out with anecdotal reports of that. West Virginia and southwestern Virginia, there was a those were identified by the UN Special Rapporteur in her 2010 report on the North Carolina. There was a study in a county of western North Carolina, I believe it was Madison County, about that was a very comprehensive study of straight pipes, where they have a different set of kind of topographic and geological problems, where it's actually very heavily sloped areas and very rocky soil. But they found, I think 5.6% of homes were discharging through a straight pipe, wastewater through a straight pipe. And then in rural Mississippi, just some anecdotal reports from a researcher over at Mississippi State, that straight pipes are pretty common in some areas of rural Mississippi as well. So so why is there so much straight pipe discharge in rural Alabama? I have one theory that kind of relates to an unintended consequence potentially of the Clean Water Act. So in these clayey soils, it's basically in many areas impossible with a reasonably sized septic system and drain field lines. It's basically impossible to get all your wastewater, including your gray water, into the ground. So there are homes that do just treat the so-called black water, the sewage and kitchen waste, or the toilet and kitchen waste in a septic system, and then illegally discharge gray water to the surface. But I think because discharging gray water to the surface is illegal, that's probably not a very popular option. It's illegal under the Clean Water Act. So when conventional septic systems, when people do try to get all their wastewater into the ground and conventional septic systems fail, and the alternatives are often too costly for poor rural households, households learn that septic systems are a poor investment. Okay, so straight pipes become very widespread in an area, and then like I was saying earlier, when everyone's neighbor is using a straight pipe and people have heard that septic systems are failing, you know, people who invest, say $2,500 in a septic system and it just fails in a short period of time. And unfortunately, a failing septic system often backs up into the home in these areas. So it can back up into the yard, which is bad enough, but if it backs up into the home, it's a real disaster and cost for the homeowner. So the incentives to actually try to install a working on-site wastewater system are not that great in a lot of areas where straight pipes are very common. Once straight pipes become so common, the problem becomes too large to be addressed by a health department, and it's too expensive, and too many households are out of compliance. So there's not much of an incentive to for the health department to really make sure that people are installing properly operating septic systems. The trigger in at least Hale County, where I work, for the health department to investigate the status of a septic system is a neighbor complaint. So if someone from the public complains that someone has a straight pipe and is not properly treating their wastewater, the health department is required to come out and investigate. But in most of the, at least the unincorporated areas of these counties, otherwise there's not a real trigger for that to happen. I have heard anecdotally that, that there is some selective enforcement, that the health department in some places is enforcing the use of a permitted system for households that they know can afford it. So it's possible that the health department is kind of looking the other way for poor households that they know are not going to be able to afford one of these alternative systems if they live in an area where a conventional septic system won't work. So just moving on, that's just one theory for why this is happening, based on some observations and talking to people in rural areas of Alabama. So we have a big problem. So so what's next? Hopefully we can come up not just with some findings to describe this problem, but some solutions as well. We don't have the resources to connect everyone to sewer, especially these extremely these households that are extremely distant from concentrated populations and which don't have the money to afford their own system and can't pay, often can't pay a high sewer bill. So in terms of households with septic systems, we think we identified some possibilities to make a difference. So we're going to do some education and outreach to homeowners in collaboration with the University of West Alabama and the Alabama Onsite Wastewater Training Center. And also some small monetary incentives towards proper inspection, maintenance, and pumping. So we're trying to implement a program where we have an outreach event to inform and educate the homeowners and then give them a voucher to actually have someone come out and do an inspection of their system and see if it's operating properly, and to get that system pumped as well. And then we want to decrease barriers to homeowners having their systems inspected, pumped, and repaired. So basically getting homeowners into contact with the licensed installers and pumpers in the area and giving them contact information through a refrigerator magnet that actually has a list of the contact information for the licensed installers in that county. We also want to, we're also going to form a committee to study and report on the feasibility of alternatives. So whether that would be alternative or engineered on-site wastewater systems, community-based systems, so smaller so-called cluster systems, or what I think should be the first option if it's at all possible, connection to an existing sewer system for people who are often just outside of a sewer system or just outside of city limits. There are many places that I've seen where you have people a quarter mile away from an existing sewer system or even a wastewater treatment facility that are not connected to the system because they're outside of the city limit. What about for those without septic systems? So we still want to do education and outreach to homeowners to inform them about this problem, especially with regards to decreasing exposure of their kids and their household pets, their indoor-outdoor pets, to raw wastewater. We also are we're forming the committee as well that I mentioned. And many of these areas with straight pipe are close enough to be connected to sewer, hopefully affordably. And we're looking into options to collaborate with USDA Rural Development on doing some expansion of existing sewer systems. We're interested in that as well, and have talked to some people at USDA about that. We're also potentially interested in looking at an exemption for gray water discharge to the surface in specific situations. So when you have households that are very far from an existing sewer system, are in an area with an impermeable soil, so a conventional septic system won't work, and where those households are poor, that that they might be allowed to discharge their gray water to the surface and try to treat their their toilet and kitchen waste, their so-called black water, in some sort of surface infiltration system. Whether that's feasible or not requires more investigation. A lot of these soils really just don't take water when they're saturated during the winter. But those are things we're interested in investigating. So if you're interested in partnering with us, it'd be great if you want to get in contact with me by email. Hopefully my email will be listed after this webinar. So if anyone is currently doing human-specific fecal indicator through qPCR or PCR, Bacteroides species, for example, or gastrointestinal pathogens by any method, we'd be interested in getting you some samples if you could do the analysis and possibly going in with some proposals to collaborate to investigate this further. Also, data analysis of soil and demographic data. We're making some headway on that, but for those who've done sort of spatial analysis of data, it'd be great to have some collaborators for that. Also, exposure pathways and quantitative microbial risk assessment. We're also looking for donors to fund pilot implementation of solutions like hooking up small communities to nearby sewer, decentralized systems, and alternative on-site systems. I want to thank the project funders here, especially the USEPA Gulf of Mexico program that provided the bulk of the funding for this work thus far. The USGS through the AWRI and the UA Center for Freshwater Studies. I have a lot of collaborators. I'm not going to read this list of all these collaborators, but I am happy to open it up for questions now. Hopefully some have come in through the system and I'll be able to read those. That's it, and I'll pass it over to Heidi.
Okay, thank you, Mark. That was an excellent presentation and far more eye-opening than I was even expecting. I'd encourage folks that are on the webinar to go ahead and put questions there into the question chat box so that we can see them and take a look at them there. Let me, I have a couple of questions to put out there, but first I wanted to put a plug in for a couple of EPA-related programs and aspects of the Decentralized Wastewater MOU partnership that I think could be helpful, both Mark, to yourself and to your research efforts, as well as to participants on the webinar. The first is just to make sure that you're aware of our annual event, which is Septic Smart Week, which is the third week of September. So that is coming up this fall, and that is a week where EPA does a variety of social media. We put additional resources on our website, which is just epa.gov/septic, and there you'll find the toolkit that has a number of homeowner resources. So the program is intended to provide outreach and education to homeowners about proper septic system maintenance and repair. So I'd certainly encourage everyone to take a look and utilize those handouts. There are door hangers. There's, you know, all sorts of brochures on how to be a good septic neighbor, and there's a number of things that we're working on for this year, for 2017. Also, just with regard to the partnership, Mark, you mentioned, of course, the USDA's Rural Development Program, which is a fantastic financial and just categorical resource for funding these kinds of efforts to get homeowners with safe, affordable sanitation services. We are also working with them as part of our efforts through Septic Smart and the MOU partnership. And I would just also say that, Mark, both within my office, the Office of Wastewater Management, and the Office of Environmental Justice within EPA, that this issue that you've covered today is something that's of paramount interest to all of us. So those were just a couple things that I wanted to put out there. Just a couple of questions, and again, encourage anyone to add some up there into the box. When we're talking about the counties that you were covering in your presentation, is there a particular technology with regard to on-site systems that has been demonstrated to be effective? I have read the articles that you mentioned, and I do recall the installation of some systems, but then you still run into the clay soil problem. So I'm just curious from the standpoint of the topography and the situation with the homeowners and mobile home owners, if there is a technology with on-sites that you have seen or that could be utilized on a widespread basis to address the problem.
Okay, yeah, good question. So from what I've heard, there are anaerobic systems. These are multi-chamber systems with a pump that have been successfully implemented and worked for a number of years in some of these settings. From talking to Tim Wenger and his installations that he does in Hale County, he said that mound systems often work. Others have told me that mound systems, which are a fairly inexpensive alternative when it comes to alternative systems, he said that others have told me that mound systems will start to fail after a short period of time as well, just because basically at the bottom of the mound, you still got that impermeable soil. There are options of course, to bring in like a good sand fill and use that. And have like a recirculating sand filter. That's been attempted in some areas that I know of in North Carolina, where you basically filter through sand and then eventually it's discharged to the surface. From what I've heard, that hasn't really been successful in North Carolina, and so they've had to individually permit each of those systems, and they're having a lot of failures. At least that's what I've read. Based on the evidence from North Carolina. But I would say one of the first questions that I always get when I present on this is people are looking for a technological silver bullet, like a cheap system that can protect health and the environment in these in this sort of geology. And honestly, I just don't see it at this point. At least not affordably, I should say.
Okay.
So if it's all right, I can go through some of these questions that were typed in.
Sure.
Okay. So Melissa May asks, are the billions of pathogens discharged per day numbers based on actual samples or average presence in wastewater? That's based on average presence in wastewater in the literature. Phil Z asks, of the permitted systems, how is the effluent surface discharge handled? So permitted conventional systems discharge to the subsurface. So they discharge to a drain field and the wastewater goes into the subsurface. Theoretically, there is, theoretically, if you have enough, long enough field lines, basically, enough area of at the bottom of the trench to get the wastewater in, you could feasibly, get that into the subsurface. In practice, there are limits to how long the field lines can be, and depending on the pattern of wastewater use per day and how many people are using the system, in some places it's probably just not feasible. But surface discharge of wastewater requires an NPDES permit, individually permitted, and that's really just not a feasible solution for most households. So Eberhard Reader says, during inspections, did you encounter combinations of laundry discharge, straight piping, and black water subsurface disposal are unknown? How would these be characterized? It's really hard to say. So we couldn't really differentiate. And I want to be clear that I only went out for some site visits for on-site inspection. I was not doing that work. That was Robert and Lynn Jones from Down to Earth Incorporated, based in Camden, Alabama. So we couldn't really tell. So it's possible that some people who have straight pipes, it really is just a gray water discharge. I've heard, I know of a couple people, I've met people who say that that's what they do, but we really couldn't differentiate there. So that's an important distinction. I have to say, of the straight pipes that I've seen that were discharging to a place that I could actually get to, there's toilet paper and stuff. I mean, it's obviously not just from the laundry. So Christine R asks, the picture of the straight pipe to the ditch didn't seem to have any evidence of solids or toilet paper. So how do we know that's actually a straight pipe? So I think it's very likely that home, it was a buried straight pipe. It was very hidden. I think it's very likely they had a septic system with a filter on the back end. But yeah, it was the middle of the day also, and it was a very dry period of the year. We didn't see any evidence of wastewater coming out of that pipe when we were there, or sitting in the system. Granted, we were there in the afternoon, so if they had used it in the morning and gone to work, it would have dried up on that hot summer day. Christina H. asks, has Alabama reported decentralized needs in the EPA Clean Watershed Needs Survey to gain attention to infrastructure needs in the Black Belt? I do not know. So I don't know whether the state has done that or not. That's a great question. If anyone is here from the state and wants to give feedback, from the state of Alabama wants to give feedback in the questions or in the chat, that would be great. Mary Music says, have you researched a low-cost treatment solution, maybe a surface water discharge disinfection system, rather than infiltration in high water table areas or clay soils? So we have looked into that. Yeah, I mean, we're really hoping that that something can be developed. Exactly what it would be, I think, is up in the air. The big problem in Alabama is that if you do have a system that discharging to the surface, you need to have an individual NPDES permit for that home. So we could develop the best system in the world, but if the homeowners are not able to maintain a permit, then I really don't see how it's going to make a big difference. I mean, it would be wonderful if it did. Okay, but if anyone is working on some new technologies and wants to discuss those with me, I'd be happy to talk. So Susan Dingman says, are there any test solutions for wastewater management in black belt soils planned as part of these studies? Not sure exactly what you mean in terms of test solutions. You might mean technological solutions. I would just go back to the things that I was saying to others. So if you can't get water into the ground, it's really hard to have a legal solution because of the surface discharge issue, unless you have individual NPDES permits. So one thing that's been proposed is small clustered systems that would have treatment surface discharge, but it would be clustered among a number of homes, and that you'd have someone managing that. For decentralized systems in Alabama that are a little bit larger, in Mobile County, a popular model has been the existing utilities, the existing wastewater utilities, actually build decentralized systems and maintain those systems. And they're actually a moneymaker for these utilities. In Mobile County, strangely, there's actually utilities competing with each other in the same geographic space. So they actually have an incentive to expand and get to communities and hook them up to a compliant system before other systems do. So Christina H. says, Puerto Rico has severe issues with lack of wastewater disposal and treatment like areas of the South. Yeah, that's, I'm sorry to hear that about Puerto Rico. If you have more data on that, it would be wonderful as we try to collect evidence that this is a big problem around the country. We would love to know more about Puerto Rico. If you could email me, I'm gonna type my email in here, and hopefully it just pops up at the bottom. If not, it is listed. The organizer listed it a little bit higher up. Okay, sorry, I lost my place when I was looking for it. Yeah, there are a lot of questions. I'm probably not going to be able to get to all of these, but let me run through and try to answer a few. So you mentioned Clean Water Act several times. Did you find many homes that had straight pipes into the waters of the U.S.? There's no doubt that that many of these, and I'm a little confused with the waters of the U.S. Being in place and now no longer in place. So what actually constitutes waters of the U.S.? But these are being discharged off into trenches. They're going to a low point, so they get off the property as soon as possible. So yeah, I'm sure these are violations of the Clean Water. These straight pipes are violations of the Clean Water Act. So Michael Hines says research is great, but a solution to straight pipes is known. Clustered systems of secondary treatment, disinfection, and surface discharge. Alabama will not allow surface discharge, and even more economical than advanced on-site clustered system costs in poor areas will require SRF or other funding. Your thoughts on convincing ADEM to allow a solution? Yeah, so Michael, we've had many meetings with ADEM and the health department trying to talk to them about a solution that involves surface discharge. Like I was saying, it's going to require individual permitting of each discharge according to ADEM based on the Clean Water Act. So yeah, clustered systems are a potential solution when you have a number of homes in an area, and I think that it's something that we're really going to explore. At the same time, there are some homes that are so isolated that clustered systems really are not feasible in some of these areas. So I don't think there's a one-size-fits-all solution with clustered systems, but clustered systems are definitely a part of the solution. So Patrick Calvert says, exemption for gray water. Would this require the discharge be considered a permitted discharge under CWA? Yes, that is correct. As I mentioned, thanks. Patrick did ask that question before I said that too. Christina H says, Orrin Shanks at EPA's lab in Cincinnati has done some MST related to on-site systems. That's great. That's great to hear. MST is my yeah, I've read some of Orrin's papers, and yeah, that work is great. I would love, if Orrin Shanks is listening, I would love to collaborate on getting you samples for microbial source tracking. Melissa May says, how did you get people to participate in the septic survey? We found it very difficult to get anyone with unpermitted systems to participate in this kind of survey, especially in rural areas. Melissa, that's a great question, and that is really down to the partners that I was able to collaborate with. This work is completely, in my opinion, completely infeasible coming from a university with university employees and students. We have collaborators. Robert and Lynn Jones have lived in Wilcox County for decades. They know many people in the community very well. Their jobs made them kind of put them out in the public where they met people through their work. Their approach is extremely innovative and was really inspiring to see. They actually go to a community the day before they're going to go out and do the inspection, and they go to someone that they know through their personal connections, and they talk to that person about what they're going to do. They then rely on those people to spread word around the community that these people are coming out the next day, and it's to help find a solution to this problem. And they have not had any trouble using that approach. I have to say this is not, I want to say again, this is not something that just anybody can do. It requires a lot of soft skills and a lot of history in the communities in order to make this happen. Robert was the environmental director for Hale County as well, where the other samples, where the other sampling was done. And as Robert says, his wife is extremely personable and can get anyone to talk about anything. But yeah, this work is really tough to do, and I'm really in debt to Robert and Lynn for making this happen. So can you share social media handles for Elliott, Septic Smart, etc.? Yeah, I'm like yeah, I'm only 42, but somehow I do not have Twitter or Facebook. My wife has Facebook, and my name is on the second half of that. But I will make it a resolution to get on onto Twitter and onto Facebook and try to spread some of this as this work is going on. Heidi or anyone else, if you want to share some of that information about social media with Septic Smart or other EPA programs, Office of Water, that'd be great if you want to disseminate that either verbally or another way.
Sure. The website, and we'll put this in the answer block to the materials as well, is www.epa.gov/septic, and that will take you to the main page that has information on Septic Smart Week and the toolkit that I mentioned, and we'll make sure to disseminate that to all of the people who also registered for the webinar.
Great, thanks. So Sina Pruder says, would it be possible to establish a state working group to address these types of issues? I live in Hawaii, in the state of Hawaii, and we're trying to figure out solutions for upgrading cesspools. Yeah, I've heard that Hawaii cesspools were the standard for a really long time, and they're now attempting to deal with that and retrofit those systems, get people to put in septic systems or another form of on-site wastewater treatment. So I think it'd be great. I mean, I think this is something that if we're going to do a state working group, state work group, it would probably be something that that EPA would have to be involved with, or some states that actually have some funding to make this happen and get people together. But I would love to expand this beyond Alabama. That's one of the main long-term goals of this project.
Yeah, I will. This is Heidi. I'll just echo that as well. I think that's a brilliant idea, and I'm very interested in following up with Sina and yourself on that, and to include communities like Puerto Rico, which have similar but very different issues. Yeah,
and if we want to meet in Hawaii, that'd be great. So Paul Hamrick says, that was a joke. Paul Hamrick says, last year I read where only 5 cents of every EPA Clean Water Act dollar to the states was spent on decentralized sewer. How can we get more at solutions as solutions come in various ways? Yeah, Paul, I think that's very important. I just think that the reality is that when you have these centralized utilities, it's very that are connected to the governments when it comes to grant writing and things and channeling money. It's so much easier to go through the municipal systems. But hopefully work like this and work by others that is showing what a problem on-site wastewater can be in some of these rural areas of the U.S. That will be able to leverage some more resources to help make a difference. Lynn Brodus says, I've heard that USDA's rural water program was eliminated in President's draft budget. What do you see as future of programs funding? I had not heard that. I really hope that's not true. And I don't know. Yeah, I really don't have any insight into the program's funding. Maybe Heidi does?
Yes, so that's correct. That was proposed under the President's draft budget, but we still have several iterations to go until we have a final budget. So let's not assume anything and hope that we get some different resolution there.
Thanks, Heidi. Okay, Pete Penoyer says, what is the risk posed to domestic well water supplies? Is there generally a good stratigraphic separation from a depth and vertical barrier perspective? So that's a great question, Pete. There is some, so in these areas we have, so let's talk about wells. In these areas, a lot of people are on wells, but at the same time, through rural water funding, a lot of these the piped water systems are spread throughout these rural areas. So the water systems are much further spread than the wastewater systems. So you can go down rural highways in Alabama, and every couple hundred, every, I don't know what it is, a quarter of a mile or whatever, you'll see fire hydrants out in the middle of nowhere. So the water systems are spread pretty well across these areas, but there are a substantial number of people that do have wells in some of the really rural areas, or people who prefer wells and don't want to hook up to a water system because it costs money. So or they prefer their well water. So yeah, I would say there should be good separation between the well and the surface, and if you have straight pipe discharge to the surface, it shouldn't be getting into the well as long as there's it's a good protected wellhead, and the well is screened at an appropriate depth where there is an impermeable layer in between. The reality is that's probably not happening in all cases. There's another concern is there are a lot of abandoned wells in Alabama, and there's not a great incentive to properly decommission an abandoned well. So they can act as conduits to get wastewater that's on the surface down into depth. Also, with these large pipe systems that go all around the county, there are issues, of course, like everywhere in the U.S., with the quality of that infrastructure and with potential infiltration. So these water supplies with low resources and extremely wide geographic spreads have a lot of trouble keeping up the quality infrastructure, and sometimes apparently maintaining a high pressure in their systems that prevents infiltration. So you could potentially get infiltration of surface discharge wastewater into those pipes, into those piped water systems. Although, as far as I know, that hasn't been demonstrated. When it comes to the subsurface and septic systems that are discharging to the subsurface, there is evidence from a lot of areas that that's a big problem. From Wisconsin, for example, there was a big study showing the presence of enteric viruses in well water associated with septic systems. There's evidence out of Arizona related to cryptosporidium in wells. A bunch of different studies have shown that can be a problem. With surface discharge and this really impermeable clay, I doubt we're getting much infiltration into wells at depth when wastewater is on the surface. So unless the wellhead is unprotected and the wastewater is getting right to the surface when it's moved by rain, for example, I think that's less likely. So were any consideration? Oh, Duncan Welch asks, were any considerations given to chlorinated surface on-site disposal options, spray irrigation with mechanical treatment plants? Yeah, so we've there are spray systems even for some towns in Alabama. The problem is it's basically relying on for much of the year, I should say, not for the whole year. When the clays are really dry, they actually crack, and you can get wastewater into the ground. But when the clay becomes saturated, which it would with a spray system, basically you're relying on evaporation to get rid of the wastewater. And I've just visited a wastewater treatment plant in Uniontown where the spray field is actually basically acting like a lagoon cell. None of the wastewater is none or very little is going into the ground. There's some evaporation, but even under dry conditions, it's flowing out into a stream. Okay, Rusty Smith says, what are some examples of sewered areas in Hale and Wilcox County? Can you provide any observations, anecdotal or otherwise, on wastewater discharge in commercial public facilities in unsewered rural areas? Okay, so sewered areas in Hale County, there's a sewer in Greensboro. There's sewer in Akron, and maybe, I think, part of Moundville. That might be on the Tuscaloosa County side. Is sewered. I'm not sure if the sewer in I think the sewer does go partway into Hale County and Moundville. And then in Wilcox County, Camden has sewer, and I'm trying to remember the other town that has sewer. It might be I want to say it's Pineapple, but I'm not sure. But there are sewered areas. You know, it's basically the towns. I think there's another small town in Wilcox County as well that has a small sewered population. Can you provide any observations on wastewater discharge in commercial public facilities in unsewered rural areas? Let's see, commercial or public facilities. Do you mean like Rusty? You may mean public recreation facilities. Or commercial recreation facilities. I'm not sure. So there are recreation areas on the river in Wilcox County that we think, and we haven't actually done sampling there, but we've heard that that wastewater contamination is a big problem, and people know not to swim there after it rains. I don't know. That's just anecdotal, so I really don't know. But if you want to like email me and ask me get more specific with the question, I'd be happy to look into it. Okay, Michael Hines, Mark Toy has left, so I'll skip that one. Michael Hines says, buried sand filters with surface discharge to roadside ditches worked great in southern Illinois for years. Yeah, so that would be like a recirculating sand filter. Those have been tried in North Carolina, I know, and apparently they've had to be permitted individually, and they're constantly out of permit. It's better than nothing. A buried sand filter is better than nothing, but it's not really ideal, and it's not going to meet permitting for the bacteria and the nutrients. I mean, I think it's very unlikely, at least not under all conditions. Karen Irian says, what about facultative stabilization ponds or mechanical aerated on-site systems? Yeah, so those are options that can be appropriate in certain cases. There are cost issues. It depends on the concentration of the population and whether you want to do those whether you want to do those house by house basis or in some sort of small cluster. Mechanical aerated on-site systems have been successful. They're one of the examples that I listed, but unfortunately, they're just far too expensive for most of the rural poor in these counties in Alabama. Martin Christ says, based on your water quality monitoring, is there one or a few measurements you recommend for tracking the pollution in a creek back to the source? Preferably no 24-hour incubation necessary. So, Martin, we're actually trying to find some to see which parameters might be most useful. Right now, that work is still ongoing. If you are looking at a specific case, and you're trying to track pollution back to the source, it's going to be challenging without using either a molecular microbiology method. It doesn't require 24-hour incubation, but it would actually be like polymerase chain reaction or something where you're actually looking for specific microbes, not a larger category of E. coli, for example, that's very broad and captures a lot of stuff, not just human source. Yeah, depending on the budget that you have and or the facilities that you have access to, there are some options. But for most small scale or informal sampling activities, it's really unlikely that that you're going to be able to find a solution that can confidently track wastewater back to the source for a low budget or informal sampling. Mary Usick says, you mentioned the need for individual MPDS permits for direct discharges. Texas has written an MPDS general permit using a standard design with lower cost technology. Everyone uses the general permit under this design. Okay, so that's great. In Texas, I'd be very interested in hearing more about this, that there's a general permit, but still you need to meet the permit, and that's the problem with surface discharge systems, unless they're advanced systems, which get too expensive. But Mary, if you can give me more information on that general permit, I'd be really happy to hear that in the context of developing solutions for this part of the country. Michael Hines says,
and I think I might have access to it too. It's Heidi. So
great. Yeah, great. Heidi, if you could email that to me, that'd be great. Michael Hines says, other states have developed blanket FEDS permits to cover single-family homes. That's the same thing. Thanks, Michael. Phil Z says, just a clarification on my previous question about permitted systems. Given the impermeable soils, what requirements do health departments have for permitted systems in terms of treating and discharging the raw sewage? So it's a standard MPDES permit under the Clean Water Act. I can't remember the BOD, nitrogen, and coliform numbers off the top of my head, but they're sort of standard surface discharge values. Greg Graves asks, what about spray irrigation like used in Texas? Yeah, so spray irrigation is something, like I mentioned before, that's been considered and been used in some systems here. You're not going to get surface infiltration with spray systems in these impermeable soils, so you have to rely on evaporation. That could be feasible for like the summer, the dry part of the year, the hot part of the year. When you get to the winter, when the soil is is often saturated, and you've got it raining frequently. It's just probably not feasible. You're going to end up getting that wastewater running off the site. The state of Illinois, Christina Heinman says, state of Illinois has a general permit for surface discharge. That's great. Another general permit. I'd be happy to see that. Andy Alfonso says, are lagoons used in this area? There are lots of wastewater lagoons for towns. So it's the most common technology in these counties, the counties where I work, for the towns. I don't think there have been many individual site lagoons or constructed wetlands, but yeah, multi-chamber lagoons are very common in these areas. Howard Redfern says, what impact from these straight pipe discharges have communities seen on mosquito control? You know, that's a great question. It's something that we've talked about, but we have not yet explored that. So we're very interested in it, you know, in the context of Zika, et cetera. So Howard, if you are, you know, you're in the, if you work in the area of vector control, mosquito control, and you're interested in trying to collaborate on doing an investigation or putting in a proposal with us, that'd be great. Just contact me at that email address. And that is the last question. So thanks, Heidi, and thanks everybody for sticking around so long. I know we went well over time. I'm looking forward to hearing from you by email. I do have a number of things that are due this week, so I might not get back to you right away, but I will respond to everybody who emails me about this.
Great. Thank you so much, Mark, and thank you for everyone for staying on the call and for your questions. This webinar will be uploaded and available on the EPA website, and we'll make sure to have Mark's email and information available there as well. Thank you.